this video we're going to take a look at the calculation of the concentration of HCl, hydrochloric acid, for one of our titration experiments. So it's a question that's frequently asked. We're asked to figure out what was the concentration in moles per litre. So if we take a look at the information given in the question, we start highlighting the key pieces of information. So first thing we know is that it's a 0.05 molar solution of sodium carbonate, Na2CO3, so that's this chemical compound. It was prepared and then used to find the concentration of hydrochloric acid solution by titration. Some pieces of apparatus using the equipment are shown below, so I've cut that piece out, we don't need it. So we're focusing on the calculation. For each titration, 25 centimetres cubed of the sodium carbonate solution was measured. So anything that's got to do with the sodium carbonate, I'm highlighting here in yellow to keep all of that information together. They were measured into a conical flask, and the table shows the volumes of hydrochloric acid. Okay, so I'm going to change highlighter colour here. I'm going to be looking at hydrochloric acid. What do we know about that? So you'll notice they have a rough titration first. We don't include that in our calculation, so that's just kind of there to give us the ballpark figure of where we should be looking to stop the titration when we do it more accurately. So it's a rough one. We do it at the start, we just let it run quite quickly. We start slowing down when we start to see a colour change, and we now know after the first rough titration that we have 23.2 centimetres cubed. In or around there, I should start slowing down the addition of the hydrochloric acid. And when they did that for this experiment, they found that when you started to slow down around 22.7, 22.6, that's where the money was. So that's where the reaction actually started to happen. So you don't include this. What you will want to do is get the average between these two, however. So the average there, if you add 22.7 and 22.6, and to get the average you add the two numbers and you divide by 2, and if we do that, 22.7 plus 22.6 and then divide it by 2, we will get 22.65. So we're going to use that in our calculation later on. So it's got to do with the hydrochloric acid, so I'm going to keep that in blue because I will come back to it in a moment's time. It then tells us the equation for the titration. So I've highlighted my Na2CO3. I'm going to put this in blue because it's relating to the hydrochloric acid. I also know then about the reaction is that I added 25 centimetres cubed of the Na2CO3. So I go back to yellow. So Na2CO3, 25 centimetres cubed. And again, it's 0.05 molar. So how we're going to do this is by a process known as first principles. We're going to break down the calculation into steps. They're all fairly intuitive. Just try to remember the headings for yourself if you find it difficult. So the first step that I need to do is I need to convert or figure out how many moles. So how many moles of the Na2CO3 were used. So how many moles of Na2CO3 were used, and what I can do to do that is I like to draw a little sketch of where they are. So remember the Na2CO3, he is in our conical flask, and in the conical flask I had, if we go back up, you'll see that it was 25 centimetres cubed. So inside there it's 25 centimetres cubed, and it came from the volumetric flask where it was 0.05 molar solution, which actually can be written as 0.05 moles per litre. So moles in 1 litre. So straight away what I need to be thinking of is, okay, if I had 1 litre of it, I would have 0.05 moles, but I don't have 1 litre, I've got 25 centimetres cubed. So I'm going to convert the volume. So I'm going to convert 25 centimetres cubed into litres first. And that's going to allow me to say, well, what proportion of a litre do I have? And then I can scale down the moles with that. So how I like to do it is I like to say that 25 centimeters cubed is the same as 25 milliliters. The milli here actually gives us a bit of a clue as to what to do. So we're going to do 25 by 10 to the minus 3. Now how do I deal with that? Well, if I put in my decimal point, the minus 3 tells me to move the decimal point backwards 3 places. So I'm going to go 1, 2, I could put a 0 here, and then it's going to be 3. So my decimal point now lands here. So it actually is 0.025, and I changed, just so we're clear, I changed the milli part into times 10 to the minus 3. So that's times 10 to the minus 3 told me to move the decimal point backwards 3 places. And now I have very quickly calculated how many litres do I have. So what I want to do now is, if I know I don't have 1 full litre, I have 0.025 litres, I need to then scale down the moles. So if in 1 litre I have this many moles, how much do I have in this many litres? So what I'm going to do is I'm going to say I had 0.05 moles in 1 litre, so per litre, but I'm going to now multiply it by 0.025. So you can think of it as multiplying by what fraction you have, what proportion of a litre you have. I like to use it or keep track of it by using our units here. So I have multiply by a litre, divide by a litre. So that's another way you can kind of rationalise this in the calculations that you're doing. So this is going to give me how many moles are inside. That's what this is calculating. So how many moles are in here? So I'm going to go 0.05 multiplied by 0.025, and what I'm getting is 1.25 by 10 to the minus 3. Now if you don't like the look of scientific notation, you can convert it back out, and I'm going to show you how to do that again. So I would just add a few zeros here in the front, just so it'll allow us to move the decimal point. If it's by 10 to the minus 3, what it means is you're going to move the decimal point backwards 3 times. There's 1, 2, and then we're going to have 3 here. So we've got 0.00125. That's how many moles of sodium carbonate I have inside in the conical flask. And remember, moles are just a way of counting atoms. That's what we're actually counting. We're counting how many of those Na2CO3 molecules we have inside in the beaker. And what we know is that Na2CO3, that's reacting with the HCl. Now, the next thing we need to do is find out how many moles is it going to take to completely react this 0.00125 moles. And how we are going to do that is we're going to have to look at what is it reacting with. So remember, it's reacting with HCl. So what I need to do is calculate the moles of HCl. So the moles of HCl required for reaction. And how we are going to figure that out is we're going to actually look at the balanced equation, because the balanced equation tells you how much of each thing you need to add. And if we take a look, for every one of the Na2CO3s floating around down here, I need to add double that amount of HCl. So for every one here, I needed to add double. So I actually can figure out the HCl part pretty quickly, because I know, according to the balanced equation, if I had one of the Na2CO3s, I must have 2 HCl's to go with it. So I'm going to now say, well, if I had 1 mole, it would be 2. What if I had 0.00125? How would I do that? Well, what I'm going to do is I'm going to double it. So if I double that, then what I'm going to have is I'm going to have 2.5 times 10 to the minus 3. And that's how many moles of HCl I would have added into the conical flask when I was dripping down the HCl. I would have added had to have added 2.5 multiplied by 10 to the minus 3 moles of HCl for that colour change to have occurred in the conical flask, for us to go from it having the yellow colour to the kind of pinky red colour that we saw when we knew the reaction was finished. So I now know how many moles were added for the reaction to get to the end point. What I now need to find out is how many litres there were, because remember, concentration in terms of molarity is moles per litre. So I have the moles part, I'm now going to calculate the litres part. So part 3 is calculate the volume. So calculate the volume of HCl in litres. So that's going to be blue as well because we're dealing with the HCl part. So I'm going to go back and see, and I'm going to be able to find it quite quickly because my colours now, how much in terms of volume of HCl did I add? So if we go back up and we look for the blue kind of signals here, and if I look here, I have it 22.65 centimetres cubed. So I had to average the last two that I did, and I get 22.65. So I'm going to convert that into litres. So 22.65 centimetres cubed. I'm going to change that into millilitres. You don't have to, but I just find it makes this next step much nicer. So remember, milli actually means by 10 to the minus 3. So I'm going to swap him out, and I'm going to have 22.65 by 10 to the minus 3, and it's going to be litres. So all I did was swap the milli for what it actually means, which is by 10 to the minus 3. And if I want to tidy that up a little bit more, I can actually write it as, instead of by 10 to the minus 3, I could actually have 0.02265 if you rather work in decimals. So this is how many litres I have used, and I know how many moles there are in that many litres, so I can calculate the concentration. So this is my step 4, calculating the concentration. So let's work on it down here. So 4, calculate the concentration in moles per litre. I'm going to put a capital M, and you should know that that means moles per litre. Okay, so all I'm going to do now is I'm going to create a fraction where I had the number of moles that I had, which was up here. So I'm just going to give it a colour so you know where it's coming from. So this pink number here is the number of moles. That's going to go here. So let's write that in. We have 2.5 by 10 to the minus 3. And I'm then going to write that all over the number of litres that I actually used. So I didn't use 1 full litre, I used a fraction of a litre, but that's okay. I can still write that in down here, so I'm going to add it in here. And I'm going to have 0.02265. And if I do that calculation, then I will have moles on the top, I will have litres on the bottom, so I can actually summarise it as capital M. So I put it into my calculator, 2.5 times 10 to the minus 3. And I'm going to have that then divided by what I just worked out in the last part, 0.02265. So if I do that, what I'm getting, rounded to 2 decimal places, is 0.11 molar solution. So this right here then is the concentration of the HCl. That's what we have in this experiment. So we just had to figure out the number of moles of HCl used. We did that by finding the number of moles of sodium carbonate that were used. We doubled it because according to the recipe or the balanced equation, we knew that for every one of the sodium carbonates I had, I needed double that of the HCl. I then found the moles. What do I need to find molarity? I need the litres. So I had that I started out with 22.65 centimetres cubed. I converted that to millilitres, millilitres to litres, and then I got how many litres did I use. And what we did was we said in our calculators the moles divided by the litres, and that gives us the molarity.